So the continuous industries, whether they're refineries or chemical, have a very specific focus on operator excellence and performance. And that is because they run dangerous processes, very complex and very large. It is open to other vendors, so we're very careful, since Yokogawa is also in these meetings, on what we can and can't say. So we actually began in 2006, and the center formed a year later. We are an open consortium, as I've mentioned, but it's driven by the operating companies. We go, we provide expertise where we can, we listen and we learn, and the goal being that we can take this information back and apply it to make our products better. The operating companies are the ones that say, what are the types of research that we should do that can best improve our operators? And the research is about, people and how our capabilities and limitations, so that we can apply those to make sure we can make our operators better within the reasonable constraints of, human beings, with a fundamental goal to improve the health, safety, and environmental effectiveness in the plants. So why does that matter? Surprisingly, after all of these years, from Provox to Delta V, the accident rates in these industries has not gone down. In fact, the rate has actually been going up, and the risks when these accidents happen is worse. Well, why is that? Well, the processes are more complex. They're running longer without shutdowns. So when odd things happen, operators don't know how to deal with them. And so if you look at this here, 1/3 of 100 most costly accidents happened in this 9-year period. So it's pretty impressive. And so you take it a step further, you say, we've changed so much along the way. So this is actually an old control room up here, where there's panels on the wall and operators would walk back and forth, all the way down to more modern and even large screens, state-of-the-art types of control rooms. Well, as these technologies have changed, we as human beings really haven't evolved that much, right? Maybe you got a new haircut, different clothes, but besides that, we're working completely differently, but we're still human beings. And so taking all these technologies and putting them to operators with time-critical decision-making is needed. You really need to think about, how do we have to think about our graphics, our alarming, our consoles, to make sure that we can actually process the information and recognize what's going on the screen. And not just assume the technologies can do it for you. Another way to think about this is, here's a report from the Chemical Manufacturers Association showing all of the different incidents and what caused them, from mechanical to process upsets, operator, and you notice I have that crossed out. But when you talk to people, they say, I don't know about that. We think 2/3 about is really due to operations. Well, why do you think that? Well, that's because they're your last line of defense. It doesn't matter if someone left a wrench in the pipe and so everything goes haywire. It doesn't matter if the engineers designed the graphics badly or the control strategies badly. The operator is expected to run that plant safely 24/7, 365 days a year, and handle any of these unlikely situations that are surprises just through the information we give them in the control system. And then you go on top of that, for 4 decades, right? We talked about how incidents keep getting more expensive and more frequent. This is with baby boomers, experienced operators working day on, day out for years and years and years. Well, of course, they're all retiring now. There's been a huge shift in the average age of operators just in the last 5 years. And in fact, even today, 10,000 baby boomers are still reaching the age of 65 every day. So there's a real shortage of experienced operators that really understand the process that they're being challenged to run. So the Center for Operator Performance is really based to try to get to the bottom of some of these things, to perform pure research to say, what are people capable of? How can we make them better? And so the members of this consortium have questions like, how good are my operators? Like, how do you know if your operator is good or not? How do you actually know they're an expert? If they're not experts, how can you make them more competent quicker? What tools can we use? Because we're not going to shut down the plant. We're not going to have major process upsets to train them. So what are we going to do? Is my alarm management system good? Is going off of ISA and EMUA the right thing to do? How good are my graphics? Are they designed well to help the operator make the right decisions? And out of all the possible things I can do, what's going to have the most impact? And that's what we focus on. So we perform industry-focused research. That means lots of it's in the plants, working with real operators, trying to see how they will react to situations or be better trained. And we provide quantitative answers. So oftentimes, like, we'll be asked, well, how much better will my operator be if I redesign my graphics? That is a super hard question to answer. And we have done quite a few studies trying to pick apart at that. We say, well, even if your graphics are better, if your alarm system is terrible, well, then you still might not be able to be very good. Or if the control room is so noisy or bad lighting that everything else then, is all interactive. So we keep pulling apart different things and researching on those and create information out of those. So here's just a few examples. We have a website. Every Emerson employee can access this website, read the literature. So feel free, if there's anything here that you find interesting, to go out there and learn more. So we will provide seminars and workshops, industry publications. We'll do guidelines and benchmarks. This one over here, the Display Design Handbook. Mark Nixon, key author of this particular document. Quite long, and everyone is so thrilled about it. We're actually talking about possibly turning it into a book. And then we also have our own electronic library of all of our tools and different software that we can use. So this spring, things got a little interesting, right? And I thought that you might appreciate the COVID perspective from our operating companies. So, we think about all the things we've had to deal with COVID. Well, put yourself now as an operator running a plant, all the time, 12-hour shifts going on for days and days and days. There's actually hundreds of people on a typical refinery shift, and then hundreds of other supporting people. And they have all these dangerous events they have to happen. It's not just worrying about, did my code compile? It's like, if I make the wrong decision, right, something bad could happen. Well, all of the support people, went home. And all of the training that they've done is based on collaboration, and we're having all these support people around in very rigorous processes and procedures. So all of a sudden, they were forced upon this situation where staffs are being reduced, everyone's social distancing, plan for unexpected absences because you don't know who's going to get sick, but you've got to keep the plant running and you've got to keep it safe. So the COP started having weekly calls this spring to discuss and share ideas amongst the members. And, just like us, they were doing a lot of the same stuff. So they were having a lot of video conferencing and trying different techniques to stay in touch. Teams was a big component of that, just like for us as well. They were also very creative. They had town hall meetings. They did sunrise stretches where the teams would actually all stretch together in the morning. Happy hours, coffee. They even did a block party where the families were invited into some, big teams meeting to try to, keep the camaraderie up, the communication going, and to make sure that everyone is able to be productive in this new environment. So they spread people out to minimize contact. They did things like they actually would set up a remote control room so that operators didn't have to be in the same room. They limited who could be in control rooms. Usually anyone can go in the control room, right? All the engineers, all the people that work there, so they can collaborate, maintenance staff. They locked the doors, said, nope, just the operators, just this group. You couldn't all go in the break room, which is a big part of being an operator. They have big meals together and hang out during their lunch times or dinner times. They started staggering start time so people didn't all show up at one time. They used to have a team go out in the field if they needed to work on a valve or a transmitter. And then they say, well, no, we can't have a team go out anymore. Maybe you can have one buddy, but you two got to figure it out on your own. So more stressful. And they even looked at changing shifts because they said, well, normally you'd have 3 shifts in a day. Well, that would mean that, you've got all these different people mixing at these different times. Let's go to, longer days on, longer shifts to limit how many people you're being exposed to. In some ways that we were impacted, they stopped everything that they thought was discretional. And so that means lots of projects did get put on hold. Maintenance people were reduced, electricians, contractors that were on site, everything stopped. And they even mentioned one time where they did have to bring in a contractor because they had a problem in the plant. The contractor was coming from Louisiana, Texas. And if you remember at one time, we weren't letting people from Louisiana in. So they got to the site and they had to send them home. So it was very complicated. And they, like us, are also phasing back into the office. So if you think about some of the cool things, they said, how do we keep our remote folks really aware of what's going on? They discovered being able to have, your phones out in the field and sharing video and showing equipment, and they just thought that was the coolest thing. And they also talked about that, this is a tough time, and we need to think about that our workers are probably stressed and potentially distracted, which is not good when you're an operator. And they said, it's almost like being in the holidays, because people, they're focused, they're trying to do their jobs, but there's all this other factors going on. You don't know if they have family members who are sick, or, their kids are having issues with school, or all those other things that typically we don't have to worry about. And so they really encouraged, a lot of collaboration to make sure people could stay focused and they could help them through the situation. So with that, I want to talk a little bit about some of the projects that we've been doing. What you see here is our vision map, and hopefully you can read this. We have technology, and then we have operators. And so this covers things from graphics to procedures, workstations, alarming, and automation. So a lot of things that we think about. But in the operator, you get into skills and knowledge, training, workload, job design, and organization. So when you think about these, like training is a big one that we can help with because we have mimic and simulation. Things like workload, we can actually help with some studies, but it's a common conversation about how many operators do we really need, and should their areas of responsibility be. And if you look here, you can see all of the different projects and where they progressed, where we have many that we're considering, many in progress, and a lot that are done, is how this works. I mean, this gets updated every time we meet, although our last two meetings have been virtual too. And if you look at all of the different tools, knowledge, and benchmarks that we've come up with, I highlighted a number of the ones that are really relevant to us and what we do. So expertise, understanding what's required for an operator to be good can help us. It can help us design better products. It can help us create better operator training systems. Lots on color use, simulators, which is more on the training parts again. Alarm sounds is a new one that's ongoing that we might spend a minute on if we have time. And display content or decision mapping. So with that, even handheld devices and what kind of displays work good on a handheld device. And so let's take a few minutes and talk about just a couple of these particular areas. And I like this chart showing the same different factors affecting someone's performance, where we talked about the system, the culture. There's not much we can do about culture, but it plays a big role in how effective you are. The operator, the person themselves, and then the interface. So one of the early on projects that we did was alarm rate research. And here, there have been publications made that say an operator can only handle, no more than one alarm every minute. And if otherwise, they're not very effective. And we had an LSU professor come in and say, so where are these standards coming from? And it was just common sense, right? You can't have too many alarms. You obviously can't be very good at it. He goes, but insurance companies are starting to look at the alarm floods and deciding if it's a good risk, because now they're being measured to these standards. And so are these guidelines valid? Are we doing the right things? And so they crafted tests, not on a Delta V system, to say, okay, let's do some alarm floods. And they brought in students at LSU and gave them different numbers of alarms and different time periods to see how fast could they actually take some very simple actions in the process. One of the surprising things that they learned was that how you display the alarms actually changed the students' effectiveness. And it was not at all what we were even looking for at the time. And lucky for us, we actually found prioritized alarm lists work much better than just a standard alarm summary. Our default alarm list, our default alarm banners are exactly what the operators need to be the most effective. So what did we learn from this? Well, the students were really novice operators. And yes, when they got a lot of alarms, 20 alarms in 10 minutes, we noticed that their response times were slower. and that they were even 66% slower in responding to the highest priority alarms. So they were missing alarms if they were using the time-based regular alarm summaries. So that just shows how much more productive a novice could be using an alarm list and the alarm banner. They also found that, so then they're like, wait a minute, the alarm summary is a tried and true Honeywell standard from 1979, and they're aghast. They're like, oh, no, we got to take this out, put real operators on this because this can't be true. Now, these operators, they were not that impressed with the simulation. It was very simple. And we could not get enough alarms to actually get them to have any slowdown at all. But they did say, I think I'm better with that prioritized alarm list. So what did we learn out of this? So yes, alarm presentation can help, and it impacts novice users more than experienced users, and that your experienced operators may actually be able to handle more than what the guidelines say today. So moving over to graphics, we've also done a number of work. We've talked a lot about how control rooms have changed. One of the common misperceptions is that if I just give you a photograph of what you can see in the plant and maybe put some information on it, that'll be perfect. That'll make you the most effective. Well, we actually know that makes you the least effective, because we need to take that information and present it in such a way so you can see the data, to understand it better, and to take the right actions. So you really need to make sure you're showing your information in a good way. And this has to do with content, organization, and format. And out of these, content is actually the most important, and it's also the hardest. So you might think about, you could go to a cool movie with the best CGI you've ever seen, but if it doesn't have a plot, if the actors aren't very good, you'll be like, what was the point? That is the same as content. The content of what you have on that graphic has to be good. Otherwise, it doesn't matter how pretty the graphic is or how well it's organized. And it's hard. It's really hard to do that, because you have to know, what is the operator going to do with that one display? What kinds of decisions do they need to make? What data needs to be on that to make those decisions? And we've worked on some tools at the COP to actually improve or to help determine that information. So how might you do it? Well, you have interviews. So you talk to an operator, and the questions are different depending where you are, what level in the hierarchy you are in. So at the highest level, at the overview display, you might say, if you've been gone for several days, what do you check to know if everything is okay? And you find out what those key parameters are, and those are like a starting point for what could go on an overview display. If you go down one level, now that's more of a process unit type of display. Say, what are the key decisions that you need to know? And this isn't what's an alarm, but it's a complex question. It's like, why have I lost hydrogen? So this is very specific to the refining industry. And if they've lost hydrogen, what are the parameters they need to look at to actually know? Now, keep in mind, when they're making these kinds of decisions and operating changes, they don't have a lot of time. So they're doing it fast. And that's why presenting the information well is so important. Making sure it's all in one graphic is important, so that they can, glance around and make the right action to get the plant stable. We've done things with clustering of the answers to the questions. So you say, okay, why have I lost hydrogen? Here's a whole bunch of parameters that answer that question. Well, here, all these E's answer all of these questions. So now we know that my time is up. So with that, I am going to hand off. There's more here. I was just wanting to give you a few examples of the COP. Feel free to reach out to Mark or myself, and we'd be happy to spend some more time covering this for you.